Okay, let's look at some examples of the method we just learned. Find the sixth root of z equals negative 64 and graph them. Now what does that mean? Sixth root of z means find w such that w to the 6 equals z. And we know that there's going to be 6 of these, right? Because the exponent is 6. So w is going to be r to the 1 over 6 cosine. This is a real number, right? Which means, what is the angle? For real numbers, it's on the x-axis, so it's always 0. 2 pi k over n, which is 6, plus I sine 2 pi k over 6. So let's write them down, different values. I'm calling this w0 when k is 0. So when k is 0, this is 64 to the 1/6, which is 2. That's the regular root that we know of. W1 is going to be 2, but cosine 2 pi over 6 plus I sine 2 pi over 6. W2, 2 times cosine 4 pi over 6 plus I sine 4 pi over 6. W3, 2 times cosine 2 pi times 3 is 6 pi. So 6 pi over 6 plus I sine 6 pi over 6. Two times cosine, it's going to be 4, so 8 pi over 6 plus I sine 8 pi over 6. Times 5, 10 pi over 6 plus I sine 10 pi over 6. And then it starts repeating. So you can see when it's w6, it's going to be cosine 2 pi plus I sine 2 pi, which is essentially back to 2. Let's plot them. Each of these in their polar form have r2. So they lie on the circle corresponding to radius equals 2. This has an angle of 0. This is pi over 3. Pi over 3 is 60 degrees, so somewhere here. 2 pi over 3 is 120. 4 pi over 3, 4 pi over 3, sorry. That would be, pi. So then it goes to pi. And then it goes to 4 pi over 3, which is 240. Alright, sorry. 240 is somewhere here. And then it's 330, and then back to 360. So they lie on a circle. And in fact, they lie on this hexagon thing. So it's really neat that you're finding the sixth root and they are symmetric. They are points at exactly 0 degrees, 60 degrees, 120 degree, 180 degrees, 240 degrees, 330 degrees, and then back to 360 degrees. And their lengths are all 2. Second example, find 3 cubic roots of this complex number. So we need w cubed equals z. We write z in polar form. Square root of 2 plus 2 squared plus 2 squared, 4 plus 4, 8, 2 root 2. Theta tan inverse 1 pi over 4. So in general, w is going to be r to the 1/3 cosine theta plus 2k pi over n, which is 3, plus I sine theta plus 2k pi over 3. So let's write it down. W0 is 2 root 2 cube root cosine, so k is 0, but theta is pi over 4, so it's pi over 4 over 3 is pi over 12. Sine pi over 12. W1, 2 root 2 to the 1/3. This time it's going to be pi over 4 plus 2 pi. So let's do the rough calculation here. Is 9 pi over 4, and then 1/3 of that gives me 9 pi over 12 plus I sine 9 pi over 12. And lastly, the third one, 2 root 2 1/3 cosine pi over 4 plus 4 pi this time, 17 pi over 4 times 1/3. Is that correct? Yeah. 17 pi over 12 plus I sine 17 pi over 12. Now just to verify, if you went to 6 pi, it would be 25 pi over 12, which is pi over 12, which you already have. So if you plot this out, you start with, so again, you're on a circle of this radius, 2 root 2 1/3. You start at an angle pi over 12. Pi is 180, so pi over 12 is what, roughly 10 and 60, 15 degrees. So you start at 15, and then you move on to, this is 3 pi over 4, which is 135. And then 15 times 17 is, let's see, 170, and 17 times 5 is 85, so 255, somewhere here. So you get a triangle because you're working with power of 3. Here's an application. So far we have solved equations in real numbers with x. But what if it's with z, with complex numbers? So this just boils down to what we've already done. Z cube is -1 minus I. So z is the cube root of this number. To find the cube root of this number, we write it in polar form. Root of -1 squared plus -1 squared is root 2. The angle is inverse tan of -1 over -1, which is inverse tan of 1, but in third quadrant. So it's pi over 4 plus pi, which is 5 pi over 4. So z is going to be root 2 to the 1/3, because it's a cube root, cosine 5 pi over 4 plus 2 pi k over 3 plus I sine 5 pi over 4 plus 2 pi k over 3 for k equals 0, 1, 2. We stop at 2 because the power is 3, and we are only going to have 3 different answers. And as before, these points are going to lie on a circle of this radius and forming an equilateral triangle. Okay, the last one, show that the division of complex number in polar form gives, this is a repeat. I must have forgotten that I already did this. Well, we did the multiplication one and I left you to do the division on yourself. So maybe if you are watching this video, I'll call this an extra bonus. And you can just email it to me. It goes absolutely parallel to the multiplication one that I showed. using trig identities. That's the end of this week's material with complex numbers and everything, and there are associated worksheets with it which you can complete.